Alright, geometry students, I'm going to start this Wednesday off with some good news. Actually, some really good news. First piece of good news is this is the last chapter that I will be teaching you. It's the last chapter that I can do, so hang with me. We're almost done. Here's the next piece of good news for you. We got exactly, look at your calendars if you need to, exactly 2 weeks until the last day of school. So it's getting close. And third piece of good news is this final exam that I was getting ready to give you guys. Yeah, we're not taking a final exam. This is going to be the last chapter, so I'm going to give you a quiz over this towards the end, and we're going to call it a class. So without further ado, hopefully that good news is kind of helping everybody out, kind of lifting you up during this tough time. The very first lesson I'm going to be teaching you is not 12.1. It's going to be 12.2. That's not just because of quarantine. That's just because 12.1 is just a, useless section. So we're going to start with 12.2, and it is titled Surface Area of Prisms and Cylinders. Get your notes ready, folks. Write this stuff down. I'm telling you, easy points, easy points, easy points. Alright, first things first. I wanna wrap my mind around what a prism is. I think everybody's okay with what a cylinder is, a can of pop, a can of Pringles, a can of soup, anything that looks like a can. But prisms, this is a typical geometric solid that kids, for some reason, have a difficult time wrapping their minds around. So let's go ahead and draw a prism. We're going to draw a couple pictures here. Over on the left-hand side, we're going to draw a good basic hexagon. Now, folks, this is a two-dimensional figure. It's got length and it's got width. That's it. It is not three-dimensional. It does not have height. Some people call it depth. But we're just going to draw a hexagon. Hexagon, six-sided. Let's go ahead and do this. You know what? Let's be fancy. I'd like you to make a regular hexagon, meaning all the angles, all the sides are exactly the same. Let's go ahead and do this. Let's make it kind of small. Don't make it ginormous. Just make it a decent size. Okay, trying to make it regular. Okay. How's it look, folks? Any critics out there? Mr. Kosal, that just does not look good. No critics. No critics. All the sides are the same. Put these little tick marks on them. And let's get the angle. To symbolize that all the angles are the same. Perfect. It's a regular hexagon. Now, we're going to come over here, and we're going to draw this, but we're going to turn it into 3 dimensions. Over here, we are going to make a hexagonal prism, which means you're going to take this and you're going to make this the top view, and you're going to give this whole thing some height. So let's do this. Because you're going to give this some height, you need to kind of make the base, is what we call it. I'll talk about that in a second, but you are going to extend the height of it down. So let's go ahead and make the base of the hexagonal prism. So follow me, folks. This is a little tricky drawing these. Perfect. Now it kind of looks like I took this hexagon right here, this regular hexagon, and I kind of smushed it. So it's kind of, a little bit fatter. But it's not. It's kind of looking at a sideways angle. Imagine that this is the exact same hexagon, looking at it from a sideways perspective. Now we are going to take this hexagon and we are going to give it some height. So watch what I'm doing. Some of you are going to pick on a little quicker than others. Trying to give it some height. Now in order to do this, I need to make this parallel. So where's my ruler? I've got my ruler here. So whatever that is, kind of seeing what this is right here, we're going to kind of come down here, kind of keep the same slope going. Okay. It's turning into something. That's a relatively horizontal line, so let's do the same down here. Do you see what I'm creating? Maybe. Trying to make all these vertical lines parallel. Okay. Two-dimensional figure right here. We're creating a three-dimensional figure, what we call a hexagonal prism. Okay. For some reason, the first time students draw a three-dimensional figure, it just doesn't turn out good. If yours just looks awful compared to what I'm doing right now, just laugh it off. You know, get an eraser out, try again. There we go. We have a hexagonal prism. A prism is pretty much taking a two-dimensional polygon and giving it some height, where you have a top base and a bottom base. Now, I'd like you to make this kind of see-through. So this side right here, I'd like you to make it kind of going back. You know, we can't see this edge, but we know it's behind it. I'm going to go down. Perfect. We got like a see-through hexagonal prism. All right, we have the top right here, and let's go ahead and label this, because honestly we got a lot of definitions going on here. So let's go ahead and get started. This top surface, this hexagon right here, you're going to find a hexagon on the top and you're going to find a hexagon on the bottom. We call those bases. This is what we call a base. And this is also a base. The bases are exactly the same. They are congruent. That's a hexagon. That's a hexagon. They are exactly the same. Let's see. This side right here is what we call a base edge. Okay. Now, these sides that stretch between base to base, the top base to the bottom base, here, I'm going to highlight one of these. Let's see. I got a blue highlighter. Let's see if this kind of turns out. I'm highlighting one of these rectangles right here. In fact, you have another rectangle right here. And you have another rectangle right here. And if you can visualize this with me, a little difficult, but you have a couple more rectangles behind this hexagonal prism. You have one back here, you have one back here, and then you have the one in the very, very back, if you can visualize that with me. They're all rectangles. We call these lateral faces. Might not be able to read that. Lateral. These are what we call lateral faces, and there are 6 of them. And notice how they're all rectangles as well. The bases, I'm going to put right here that there's 2 of them. There's always going to be a top base and a bottom base. The lateral faces, well, because it's a hexagon, it's going to be 1, 2, 3, 4, 5, 6. Okay, what else do we got? What else do we got? I want to make sure I get this right. Okay, this right here, this, this edge right here, connecting base on the top, base on the bottom. We call this, the book has a couple different definitions for this. You can call this the altitude, or you can call it the height. I like to call it the height. I believe the book uses the word altitude. Folks, they mean the exact same thing. It doesn't matter what they say. It's altitude, height, altitude. Doesn't matter. And okay, let's see. Trying to see. I think that's it. Gosh, I think that's it. Okay. Now we need to start talking about area, folks. Got to start talking about area. There are really 2 types of area that I need to introduce to you. One of them is called the lateral area. And I like to abbreviate it with an LA. Just abbreviations make things short, make things go a little quicker. And the other one is called surface area. I like to abbreviate this with SA. You know, SA, surface area, LA, lateral area. The book doesn't do this. This is specifically a Mr. Kosal kind of thing. But there's two areas that they're going to talk about in the book. They will, in your homework tonight, they will ask you questions. Find the lateral area, find the surface area. You need to specify the difference between these two. All right, so let's start with the easy one, folks. The lateral area. Here we go. It's sort of an equation, sort of not. The book has an equation. I'm not going to give you a really fancy equation. I'm just going to level with all of you. The lateral area is if you take one of these lateral faces. Now, I just talked about this up here. These blue rectangles. I'm not talking about the top base or the bottom base, the hexagons. I'm talking about these 6 blue rectangles. The lateral area is if you take the area of one of these blue, I'm making it blue, just so you can see what's going on here. If you find the area of one of these blue rectangles, and going back to chapter 11, which, hey, we just took the quiz on, hopefully it was okay with you. To find the area of a rectangle, you just multiply length times width. You know, super easy to find the area of a rectangle. But you find the area of one of these rectangles, and then you multiply it by the total number of rectangles going around this figure. Folks, that's the lateral area. That's it. That is it. Lateral area. Let's come over here. Surface area. The surface area, SA, surface area. The surface area is going to be the lateral area. Go ahead and write this down. It's going to be the lateral area, so what we just did over here, the 6 rectangles added together, or find the area of one rectangle multiplied by 6. It's the lateral area plus 2 bases. The 2 bases are the top and the bottom. Now they touch on this in middle school. They touch on surface area. I know your middle school math teachers talk about this. It's the reason why they call it surface area is because it's kind of like you're painting every single surface. How many surfaces do we have? Well, let's break it down. Lateral area, well, that's going to be 6 rectangles. That's the 6 rectangles. You know, visualize that with me. You're going to paint all 6 rectangles, just the outside. So you're going to go to Sherwin-Williams. You're going to go to Home Depot. You're going to get some bare paint. And you're going to, you know, get a paintbrush and slap that on. And then you're going to paint this side. And then you're going to paint that side. And then you're going to paint all the 6 rectangles. But you're not done. You haven't painted every surface. You still need to paint the top surface and that's right, you guessed it, bottom surface. So you need to add the 2 bases. So 2 times, I'm going to draw a little hexagon, and I'm going to make it yellow. That is surface area, ladies and gentlemen. Lateral area is just the rectangles on the outside. I like to visualize this as lateral area is kind of going like around the figure. Notice how these rectangles are kind of going around the figure, 6 of them to be specific, whereas the 2 bases are on top and bottom. That's basically it on my prisms. I'm going to give you a couple examples, and we're going to jump to cylinders, and we're going to keep going with this lesson. So let's jump into example 1, everybody.